For decades, software deployment meant managing a single, predictable structure. Today, that structure shatters into hundreds of autonomous, fast-moving nodes that compound their actions at speeds human operators cannot track. As these nodes accelerate, they move beyond the reach of traditional oversight. This creates a critical governance gap, currently affecting 99% of agentic systems, that most organizations have yet to name. The agents are running continuously. They are allocating resources, routing work, and triggering effects in systems of record. The policies meant to govern them, however, are entirely stationary. This exposes a structural failure in how we handle artificial intelligence. Governance is designed at build time, validated at deployment, and then completely left behind. In standard software, code pushes through a pipeline, hits a final governance check, and sits static in production. But when an agentic workload is deployed, it wakes up. Decision nodes fire continuously, moving further away from that original, stationary deployment gate. Oversight must match the velocity of the agent to remain effective. Anything slower results in archaeology, a study of history rather than active runtime control. We arrived at this point because of a previous success. Policy as code moved compliance out of three-ring binders and into version-controlled repositories. It made rules repeatable and testable in the build pipeline, but its operational boundaries are strict. Policy as code governs infrastructure provisioning. It governs configuration. It governs the exact moment a workload is released into the world, the exact millisecond the agent goes live and begins evaluating choices. Policy as code completely exits the room. The tools we use to enforce compliance were engineered for a specific environment. They assume a system is built, deployed, and then remains completely still until the next patch. Agents contradict that assumption. Autonomous systems process logic, trigger APIs, and spend money continuously between deployments. Applying a static infrastructure tool to a continuously acting multi-agent network creates a severe visibility gap. You know what the agent was authorized to do at the deployment gate, but you have zero mechanism to govern the decisions it makes out in production. Consider an inevitable scenario. A regulator contacts your compliance team to know exactly why an agent executed a specific, highly anomalous trade 3 weeks ago. Your engineering team responds by opening the system logs. They expect to pull a complete, self-contained justification for the agent's action for the auditor. This terminal output shows standard policy as code telemetry, timestamps, event records, execution traces, and actor identifiers. We know when it happened, but we cannot see the exact rule that governed the decision, its specific version, the evidence evaluated, or the approval authority. The rule existed in a repository. It was checked during the last build. It simply did not travel with the decision event. Standard telemetry fails regulatory scrutiny for autonomous systems. It forces engineers to reconstruct past events and infer compliance from fragmented logs, rather than producing a definitive citation of the rules that were followed. The problem compounds when policies must change quickly. If a sudden market event occurs, risk thresholds must be tightened immediately to prevent catastrophic financial exposure. This timeline's top track shows a policy as code update. An engineer writes a change, it waits for a pipeline run, then a deployment. It's a slow process. Meanwhile, on the bottom track, active agents continue firing decisions based on the outdated pre-event threshold. In a multi-agent system, that pipeline lag translates to thousands of autonomous actions executed per hour under compromised risk parameters. Relying on code changes and redeployments to update policy creates an unacceptable window of risk. The execution velocity of an agent network will always outpace the velocity of your deployment pipeline. Fixing this requires an architectural shift away from the static deployment model. The solution is policy as data. Under policy as data, rules are completely decoupled from application code. They are transformed into independent, version-controlled, machine-readable objects known as policy bundles. Here is the new runtime execution. Instead of a past deployment check, an agent queries and binds to a specific policy bundle, like version 2.1, in real time. It executes the action and generates a passport object, permanently fusing the action data with the exact policy citation. That cited bundle is comprehensive. It contains the exact permits granted, the denials enforced, the obligations that must fire, and the specific evidence the rule required before execution was allowed. Operationally, this eliminates the deployment lag. If you need to change a threshold, you promote a new bundle version. Every agent in scope binds to the new logic instantly, without a single pipeline redeployment. Historically, it guarantees auditability. Because past decisions are cryptographically bound to the specific bundle version that govern them, the audit trail remains coherent across time. Policy as data closes the runtime governance gap by ensuring the rule physically travels with the decision at agent speed. Transitioning to policy as data redefines the role of the enterprise architect. It represents a move away from static boundary definition toward the design of active runtime infrastructure. This split screen illustrates the difference. Left, the legacy model. The architect produces static documents, translated into code, with periodic governance reviews. Their influence is indirect. Right, the new mandate. The architect designs dynamic governance infrastructure that operates actively inside the running system. This requires delivering precise technical standards. First, the architect must define the exact anatomy of the policy bundles, standardizing how permissions, obligations, and required evidence are structured. Second, they must specify strict authority models, dictating exactly which agent archetypes are permitted to hold which policy types. Finally, they govern the promotion lifecycle, from draft to active, and they design the runtime dials that allow compliance teams to adjust live thresholds without touching the underlying code. An architect who only understands deployment pipelines will build systems that are governed at release, but entirely ungoverned in production. Evaluate the autonomous systems operating in your own production environments right now. For any single active decision happening at this exact moment, can you name the rule that governed it? Can you name the version, the evidence evaluated, the approving authority? If answering those questions requires initiating a log search, starting a Slack thread, or asking a developer, your runtime governance does not exist.